our last speaker, who is Professor Prasad Koirala, who received his PhD from the University of British Columbia in Canada, and is currently Professor of Mathematics Education at Eastern Connecticut State University in the US. He will be speaking to us on Bhaskaracharya Lilavati in the age of Common Core state standards. Professor Koirala.
Thank you very much. It's my privilege that I'm able to come here and participate in this very, very important international conference, especially because I heard about Lilavati when I was a student in Nepal. I heard his name, at least I heard his name when I was in high school, and my uncle was an astrologer, astronomer, and I remember very well, I was in 10th grade, and one time, he knew that I was good in school mathematics. And then he asked me a problem, and then I could not solve it. And then he was kind enough to, help me for the solution of the problem. But I didn't get the opportunity to learn Sanskrit and learn the mathematics in Lilavati and other works from Bhaskaracharya. But that is something that it was always in my mind, that how nice it would be if I can learn more about Bhaskaracharya and his work, especially in mathematics. And when I heard about this conference, I was really excited even to hear about the conference. And I would like to thank Dr. Agarkar and the organizing committee for helping me to be able to participate in this conference. And I'm really feeling very fortunate. And I also like to thank Dr. Agarkar one more time, because he actually said so many things I wanted to say in the previous talk. Thank you, Dr. Agarkar. And that is the topic of my presentation. So I think what I'm going to do is, we have heard so much about this strong work in mathematics in various presentations. But I think my presentation would be probably a little different from many of the presentations, because what I'm going to focus here is the Common Core standards in the United States. What are the students supposed to learn in mathematics, and how that work can relate to the work done by Bhaskaracharya in 1150. Even to think about that, it's pretty fascinating to me that Bhaskaracharya's work, done that long ago, when there were not much resources. There was mine, but there was no technology in the sense that we have them today, and how that work can be still so beneficial in today's context. So that would be the focus of my presentation. So those are the Common Core standards in the United States. So I just made a chart, and the domain, in the first column, counting and cardinality, operations and algebraic thinking, those are the domains that the students have to learn in different grade levels. And especially this is so critical to what I do in the United States. I teach prospective teachers and I teach teachers. So anything that they learn, I know it is going to multiply by at least 100 or even thousands. But the most important thing is, whatever I say to them, first of all, I need to understand, and I need to be confident that whatever I say is truly connected to Bhaskaracharya's work. And that is my problem. And I think that is what I plan to study more. But it can have a big multiplying effect. By the way, I think I would also like to say that these are the standards in the United States, what we call the common state standards. Out of 50 states, 43 states in the United States have adopted these standards. So previously, every state used to have separate set of standards, and in 2010, basically, there's a lot of politics behind that, but the common core state standards have been adopted by so many states. And the topics, as you can see, I'm pretty sure these are the topics taught in India or in different parts of the world as well. There could be some slight difference, but more or less, I think we teach probably the same kind of mathematics everywhere. So these are the 5 conceptual categories for grades 9 to 10. Actually, 6. I said 5, there are 6. Number and quantity, algebra, functions, modeling, geometry, statistics, and probability. Basically, these are more secondary topics from grade 9 to 12. And also, the Common Core focuses so much on mathematical practices. So, the belief is that every student, when they are learning mathematics, this should be there. They should be learning about it. And the first one you see, it says, make sense of problems and persevere in solving them. And this is something easy to say, as we know. But it's really hard to implement this when you are teaching mathematics to school students. Usually after 10 minutes, 15 minutes, if the mathematics is taught in a lecture format, we lose the students. So this is something very important, but it's very difficult to implement. Reason abstractly and quantitatively. Construct viable arguments and critique the reasoning of others. And these are 8 mathematical practices that they are recommended to be used in everyday teaching of mathematics. And also, this is a diagram done by the next generation sciences standards. So these are other kind of national set of standards done by the NGSS. And they have different things, but one of the components they emphasize is the integration of different subject areas, like mathematics, science, and language arts. And in this diagram, this is done by them, not by me, but they point out which of the English language arts standard is connected to which sciences standards and which mathematics standard. And this diagram is very helpful, especially for mathematicians and also the teachers of science and language arts to connect a subject with another subject. So this is that is the background, and this is what I thought Bhaskaracharya's Lilavati, particularly Lilavati. I think any of the other work can be related, but I think Lilavati would be strongly related to school mathematics. The first thing I noticed that Lilavati begins with measuring units, such as money, weights, time, distance, and so on. And when I saw that chapter, it came really to my mind that the first thing we do in mathematics is try to understand what these different terms are. And we need the definitions of terms. And especially in some other mathematics, like the Greeks, they emphasize the axiomatic system, so not just the definition, but also the axioms. But in Lilavati, the first chapter was definitions. And I think that shows the logical sequence, like how mathematics is developed and how mathematics should be developed. And the other thing that I noticed in the first chapter is the, the unit of measures were related to everyday world. That's why people actually could make sense of the mathematical problems. And remember, that is making sense of problems and persevere in solving them. That is the mathematical practices actually number one in the Common Core Study Standards. And that, I think there's a great tie between that chapter 1 and the Common Core Standards, especially mathematical practices. Another thing, like I think it is in the second chapter, third chapter, there's a lot of focus on various methods of computations. And various methods of computation and multiple methods of computation to solve the same problem. And that is extremely important in mathematics. I know, like in mathematics education, there's a theory called theory of constructivism that is pretty much used in the United States and many other parts of the world that focuses on allowing students to think of multiple solutions, so that they have the opportunity not only to solve problems in multiple ways, but also compare problem solving, and maybe even do the analysis of which solution is better and why, and what is the mathematical logic behind it. And there is, like, I think that was the same thing that Dr. Agarkar showed, like the examples from multiplication. But what I found really interesting there is, like when we divide a quantity by another quantity, and if there's a common factor, divide both quantity by the same factor, and then you can divide the remaining quantity by the other remaining quantity. I mean, this is a rule, but it's so mathematically sophisticated. I mean, it goes beyond the rule. I think it really helps students understand the logic, the abstractness in mathematics, but at the same time, it makes the computation so simpler. And because in mathematical problem solving, as we know, when a problem is difficult, then if it is hard to solve it, we solve a smaller problem and use the knowledge that we get from the smaller problem to solve the larger problem. And I think that concept of problem solving is obvious here. I think this relevance, we already talked a lot about it. But also, when students find mathematics relevant to their world, they are also more motivated. I think it's still true, like everywhere in the world. And there are situations, like for example in my teaching of mathematics, when I can relate mathematics to students' everyday world, and there are times I have to tell them that, okay, time is over. We have to continue this in the next day or next class. There's a lot of motivation. And Lilavati really provides the pathway for that motivation. And the other thing that I noticed is Lilavati presents various rules of calculation, such as inversion, superposition, concurrence, proportion. And I think it really provides opportunity for students to discuss these different rules and analyze them. It helps them for their critical thinking. And then decide which method is better in which situation. Sometimes a method could be better in this situation, and another method could be better in another situation. And it allows the opportunity for the analysis. And also, like, even in these methods, I think there are some methods that are mathematically sophisticated than the others. I mean, that's another thing that we need to emphasize in our teaching. Now, Lilavati was written in verses that, as we know, to address questions in science, astronomy. And it does the integration between mathematics, science, and language arts so beautifully. And when I showed you that chart from the next generation sciences standards, and how the common core set standards and mathematics are related to science and language arts, and basically that's exactly what we are talking about. And it's done really naturally. I mean, there is no force to integrate them forcefully. They are integrated naturally. And I think that's so powerful to get to that goal. Another thing that I believe Lilavati focuses is more on intuition. Although, like we heard in different presentations, that how the work done by Bhaskaracharya, they could relate to proof and so on. But in Lilavati, particularly Lilavati, they focus a lot on intuition rather than axiomatic system. Although there are definitions to begin with, but having focus on intuition is good for school mathematics. Too much focus on axioms will lose students. But then it also, I think, it provides the opportunity to begin with intuition and then connect them to axiomatic system. There is no problem to connect those. And the visual demonstration, like when I say here visual demonstration, it's more like the visual demonstration in mind. I believe there were no pictures in Lilavati, in the original script, but the verses are written in such a way that they allow the readers to depict pictures of problems in their mind. And that is very, very powerful. And the description is so vivid, so clear. And with those descriptions, once the people can make those pictures in their mind, then it is easy, much easier to translate them into diagrams or graphs if needed. And visual pictures are extremely important for mathematics. And I think probably that's my last one. The use of upapattis, even though not a formal proof by today's standards, they can actually motivate students. And I believe the emphasis was to explain mathematics, to help the learner to make a visual diagram in their mind and really understand what the problem is talking about. So the most important thing of mathematical proof is to convince the learners. And they can be convinced in varieties of ways. And if the readers are convinced by the visual diagrams in their head or by the explanation, then that is a very good beginning of mathematics learning. And I think upapattis, they do that extremely well. And they can be easily related to formal proofs. I think that is the end of my PowerPoint, and I'm ready for questions.
We hear a lot that there is some opposition to this common core curriculum, especially in mathematics, some states in United States. What is their argument to oppose implementation of the common core?
Thank you. In the beginning, I thought that would be interesting, but I thought I should not talk about the controversies, but you have provided me the platform for that. Thank you. The Common Core Study Standards, the controversies are usually on who created them, who was behind them. And probably I think it is, in the United States, there is a strong belief that Gates Foundation was behind the Common Core Study Standards. Like, for example, the committee, the national committees they had for the Common Core Study Standards included people who have received grants directly or indirectly from the foundation or the other foundations they were related to the Gates Foundations and so on. But I think there is less controversy about the content. Like the Common Core Study Standards, like for example in Connecticut, the state where I teach, previously we used to have the Connecticut State Standards in mathematics, and the level of content expected from the Common Core is at least one grade higher in many, many content areas. So Common Core clearly emphasized the importance of content, and we have to, and basically the idea is that our students are capable of learning more advanced mathematics in those grade levels, and so we need to teach more because they are able. I mean, I don't think there is a controversy there, but the controversy is really who created them. And another controversy, usually the Common Core Study Standards, is actually the testing. So what is happening now in the United States is, so we have the Common Core Study Standards, and then there are also two assessments, basically the national assessment. One is called SBAC, the Smarter Balanced Assessment Consortium, and then there is another called PARC. So the students are tested by these SBAC and PARC, and the controversy is there are publication companies who are directly linked with the construction of test items and who makes the profit and so on. So those are, I think those are the controversies about the Common Core more than the content. And I have not heard any people saying that, I have not heard anybody saying that students should not be problem solving in school. Nobody is saying that they should persevere when solving problems. Nobody, I have not heard anybody saying that there is no importance of abstract reasoning in mathematics. I have not heard anybody who says that mathematical modeling is not important. So the controversy is more I think it's more political.
One more supplementary question. In USA, there is a strong organization of mathematics teachers called National Council of Teachers of Mathematics. And as I recall, they prepared standards of mathematics education in 90s and 2000. What role NCTM has played in preparing this common core curriculum?
That's a wonderful question for me to answer. You are helping me all the time. Thank you. The NCTM has played a very, very important role in developing the standard-based movement in the United States. Actually, the first national standards in 1989, they developed curriculum and evaluation standards for school mathematics, and that actually set up the standards movement, and the other subject areas began to develop standards, like in 1991, the sciences standards came, I think in 94, the social studies standards came, and so on. And to answer your question more directly, NCTM had just published a book in 2014. It's called Principles to Actions. And Principles to Action is, in a way, the combination of the NCTM's previous standards and the common core state standards. So my belief is NCTM has already bought into the common core state standards, especially the content and the mathematical practices. I mean, in terms of controversy, I know there are political controversies, but in terms of content and the mathematical processes, I think the NCTM is there. Like, they have already produced more.
Claimed so many things about Lilavati. By teaching this, one can do several points you claim. Can you give an example, like from which slope, from which verse? You know, this is the object that I can have in the classroom. I can elicit this one from the students. Yeah, that is one. Second one, which you are just giving them the verse in the class and the English meaning. The students in Lilavati, you will give a verse and then the English meaning of that one.
Thank you for asking that question. And that's a very important question, especially for me, because that is really what I want to do. I mean, if you see, my audience is the American audience. They don't know Sanskrit. They don't know Lilavati. So if I talk about making sense of problems, talking about Lilavati, that is contradictory to each other. They will not be able to make sense. But what I plan to do is, I've been looking at Lilavati itself, different translations, so many presentations that were here. And but I think the claims that I made, I would not even call them claims. I think they are just a hypothesis. And I call them, I said, like, my language is can be. Okay, so I mean, that's not a claim for now. Obviously, I need to do a lot more. But I believe that every potential that I see here would be connected to a verse in the Lilavati. I mean, I'm not in that space right now, but I believe I will be, and I'm getting help from people like you, and I don't really see that as a problem. But I believe all of this, like the potential that I'm talking about, is possible to do. So here's what I think I will do. I teach mathematics education to mathematics methods courses, the teaching methodology, for the prospective teachers, and also I have a group of teachers who are already practicing teachers. They come to my program, okay? So one of the things, and the common core study standard is the mantra. Because it is the standard. That's what, in those standards, the students will be tested on. And actually, Connecticut has developed a teacher evaluation system, and that teacher evaluation system would be based on the common core study standards. Okay? So, if I'm able to make connections of Lilavati to the common core study standards, I think it will be a huge leap to take Lilavati to my audience, and I think it will spread. And I'm very, very interested to spread. I don't know, I'm biased. I like his work to be spread around the world. And I see a lot of potential. And I can actually read Sanskrit. And I have difficulty translating them word by word.
My question is, we are seeing a lot of potential. Just give us one small example. This is the potential. Then we will also feel
the small example, I think, would be probably my probably the multiplication problem. Like, for example, in that slide, various methods of computation, like there is an example. I mean, those are, I took them from Colebrook's book, which is the translation of Lilavati. I mean, I don't have the verse there. But those multiplication methods are from the Lilavati. And, but what I see there is really interesting. Like, for example, when you multiply 135 by 12, right, there is 135 multiplying by 8 plus 4. There is another 135 multiplying by 10 plus 2. Those are from Lilavati. But when the students compare those two problems, and there's a lot of opportunity for understanding multiplication better and relate that to the best 10 system of numeration. And I think like if they do 135 times 10 plus 2, and they would be able to calculate it faster. They don't need to even use the calculator. I mean, that's a huge problem. Like for students who want to use calculator able to multiply 2 and 3. But if they are converting them, in terms of 10 or hundreds or thousands into the base place value system, the computation is much easier, mathematical understanding is better, and those are directly from the Lilavati, and I think the Lilavati treats so nicely, so fluently, so well the base 10 system. And the base 10 system is one of the domains in the Common Core.
Hello sir, I'm just 13 years old and I'm doing diploma in chemical engineering in this institute. I just want to give a suggestion not just for you, but for all the maths teachers. It's the best first platform for me to give a suggestion that while giving education to us, we don't want that we're supposed to learn. We want to learn what we want to learn. Like, I'm doing chemical engineering in other subjects. When you open the book, we know that which chemical is going to be used in which purpose. But when I open my maths book, I just see estimate, derive, integrate. That's it. I know integration. I got 100 out of 80 on marks in mathematics. But I don't know what is use of integration. I don't know what is use of derivative. This is the important thing. So please, we don't want to learn, we don't want to suppose to learn. We want what we want to learn. So please try, because it's a political thing that this all things come by political matters. But what I want to say that please teach us what we want to learn. It's just not in India. In other words, I just opened some foreign books of mathematics. I opened this. I found that there's some questions, just estimate, derive, integrate. But I don't know the use of that. Yes, sir.
Thank you so much. I would like to congratulate you, doing chemical engineering, and you said you are 18 only?
Yes.
That's wonderful. Now I'm going to answer your question. I think I would put myself into the context of the question. I used to teach calculus to engineering students several years ago. In one of the engineering colleges in Nepal, I used to teach calculus. And then we had a calculus book that had a a few pages on functions, and then few pages on limits, and then it went to derivative, and then it emphasized a lot on techniques of derivative and integration and so on. Okay, so when a teacher goes to the classroom, it is expected that the teacher begin to teach class using the first chapter of the book, and that was the expectation at that time in Nepal. So I went to my classroom and I asked my students, a question to begin my class. And I told them, why are you in this class? And they laughed at me. And I said, why are you laughing? That's a very important question. And then they began to answer. And you know what their answer was? And they said, because it's required for us to do this, so we can be your class. We want to have a good grade. And engineering students I think it is natural that everywhere they're pretty good in mathematics. They're very good in mathematics. But then I said, is that the only reason that you came to my class? Because it is simply prescribed to you? So there was a confusion in class. And then I asked them a more friendlier question. I told them, do you think that the calculus will help you to become a better engineer? Do you think it will help you?
Yes.
Right? And then, I think the discussion, that question brought a lot of discussion there. Okay, and then we talk about, okay, look at that, and my college was in the foothill of a mountain, and there was a road going like that. Do you think calculus has to do with that road? And they like that question. Okay, because that gives the opportunity to talk about slope, tangent, and so on. Right? And then I said, okay, you know the irrigation from the Sept River, there is a canal, and the water flow. I believe one of you or many of you will be involved in making canals. Do you think calculus will help you in doing that? And people are very, very convinced. I did not do any pages from the book. So my first class ended with page number 0. But then after several years, some of the students, like one of my students was in London, and I was in the United States during that time. Okay, and I got an email and saying that, sir, the class that I remember the most was that first class. I think like what I'm trying to say is we should always, like I'm obviously talking about the pedagogy of mathematics. We need to make mathematics relevant to the audience. And for anything, we have to make it relevant to the audience. Like going back to the Lilavati. Thank you. Sit down. Do you have another question? Or, no, you can sit down, please. I'm sorry. I should have said that earlier. Like for example, going back to the Lilavati, right? So my audience is American audience. We speak English. They don't know Sanskrit. So if I chant a stanza and then go for word by word analysis, I think that would be interesting. But that's not enough. And to be able to integrate mathematics and language arts in this particular context, I think what I should be able to do is, can they be inspired that a person in the 12th century AD was able to put so much mathematics into poems? Is it possible for them to put some mathematics, not so much, I think that would be a big challenge, some mathematics into poems written in English? It's the same thing. But if I inspire them that the mathematics can be written in poems using English, that would be very motivating to them. And that would be very relevant to them as well.